Find the value of r to the third power given the value of r. This one can be rewritten as 2.5. So if we did 2.5 to the third power, that's the same as 2.5 times 2.5 times 2.5, which is 15.625. Go ahead and evaluate the remaining problems for your warm-up. So the Greek mathematician Archimedes wrote about the volume of a sphere in his work. In this work, he relates the volume of a sphere to the volume of a cylinder, and he demonstrates the relationship by submerging a sphere that fit tightly within the cylinder. What do you notice about the radius of the cylinder and the sphere? Well, when they place the sphere inside the cylinder, it fit snug, so they should have the same radius in both the cylinder and the sphere. And the height of the cylinder is the same as the diameter of the sphere, or all the way across the sphere, so 2 of the radiuses. Think about the fraction of water that remains in the cylinder. We're going to use this idea to help us develop a formula for the volume of a sphere. Now let's watch part 2. Consider the relationship among the volumes of a cone, sphere, and cylinder that have these characteristics. All 3 solids have the same radius. You can see they've labeled them in here with the same radius. And the diameter of the sphere is the same as the height of both the cone and the cylinder. So the diameter all the way across is the same as the height of the cylinder and the height of the cone. What is the relationship between the volume of the cone and the volume of the cylinder? We learned in previous lessons that the volume of the cone is 1/3 of the volume of the cylinder. What is the relationship between the volume of the sphere and the volume of the cylinder? Well, the cone takes up 1/3, and the sphere emptied out the other 2/3 of the sphere, or of the cylinder, excuse me. We saw in previous lessons that it took 3 cones to fill the cylinder, but there was only 1 cone worth of water left, so there must have been 2 pieces or 2 parts that the sphere took up. So 2/3 of the cylinder. What is the relationship between the volume of the cone and the volume of the sphere? Well, the volume of the sphere is twice the volume of the cone. What is the relationship between the volumes of the cone and sphere and the volume of the cylinder? Well, if we combine the empty space, which was the sphere, with the water that was left made up from the cone, that would fill the entire cylinder. So the sphere is 2/3 the cylinder. Use the relationship recorded in problem 1 to develop a formula for the volume of the sphere by using the formula for the volume of a cylinder. The sphere is 2/3 the cylinder, and the cylinder was the radius squared times pi was the base area times the height. So this piece was the base area, and then that's the height of the whole thing, like we used in the prisms. Well, the height of a sphere is the diameter all the way across. So we can replace that with the diameter. A radius is half of a diameter, so you could rewrite the diameter as 2 radiuses. But if we were to combine things here, 2 times 2/3 makes 4/3. And a radius times a radius squared can be rewritten as radius cubed. So these things get combined, and then these pieces get combined for a simplified formula that says 4/3 radius cubed times pi. And that is the formula for finding the volume of a sphere. In your workbook on page 370, we're going to add some more notes to our graphic organizer. We can label the radius and the center of our sphere. Then in the volume formula, we have V equals 4/3 radius cubed times pi. Remember, the V is the volume, R is the radius, and then the pi symbol, which is about 3.14 if we're asked to approximate. Here's a little bit more of a definition about a sphere. It says a sphere with center C and radius R is the set of all points in three-dimensional space whose distance from the center is equal to the radius. So all of these points make up the outer piece, which we call the sphere. Now we are going to use that formula to help us answer the following questions. Number 3 says find the volume of the sphere with radius of 2 centimeters. So 2 cubed is 2 times 2 times 2, which is 8. 2 times 2 is 4. 4 times 2 is 8. 4 times 8 is 32. So this is 32 over 3 with the pi symbol, and that's in centimeters cubed because volume is three-dimensional. It does not ask us to approximate, so we're leaving our answer in terms of pi. Number 4 says a sphere that has a diameter of 12 units. Our formula uses radius. It does not use diameter. So if our diameter is 12, our radius goes half of that distance, which is 6. And it says find the approximate volume of the sphere by using 3.14 for pi. So instead of writing pi, I'm going to multiply by 3.14. Six times 6 is 36, and then we multiply that by 6 to cube it. So 36 times 6 is 216. Four times 216 divided by 3. This whole piece comes out to 288. And then we still need to multiply by pi. Which is a volume of 904.32 units to the third power, or units cubed. A standard American billiard ball, also known as a pool ball, has a diameter of 2¼ inches. Find the approximate volume of the ball by using 3.14 per pi and round to the nearest hundredth of a cubic inch. So this is the diameter. The radius is half of that, so we need to divide that number by 2, which is a radius of 1.125. We're going to save our rounding till the very end. So 1.125 to the third power. Then multiply that answer by 4 and divide it by 3. Remember, the top gets multiplied and the bottom is divided. Then we're going to multiply that whole answer by 3.14. So again, this gets cubed first using our order of operations. We do exponents, multiply, divide, multiply. And we're rounding to the hundredths. So that is rounded with 2 decimal spots. So we look at the third. Since it's smaller than a 5, it stays 9/6. A cylinder has a diameter of 16 inches, so the radius has to be half of that, and a height of 14. What is the volume of the largest sphere that will fit inside of the cylinder? So looking at possible radius, going across the radius could reach a distance of 8. But up and down, the radius could only be 7 because 7 and 7 make 14. So we can't use a radius of 8 because that will go taller than our cylinder. So we need to use a radius of 7, since 2 radiuses of 7 will make that height be 14. So 7 cubed. That's 7 times 7 times 7, which is 343. We'll multiply by 4. 1,372 over 3 multiplied by pi. It does not ask us to round, so we can leave our answer like this. 1,372 is not divisible by 3, so it will not come out to a convenient decimal. It'd be better to leave it as a fraction. This art piece is called Hand with Reflecting Sphere, and it was painted in 1935 by an artist, M.C. Escher. It's a self-portrait of him in which his reflection is shown on the surface of the sphere. So you can see here, this is his self-portrait. Imagine that he is holding an actual sphere. What would the volume of the sphere be? And how would we find it? We can work with our partner to make up a plan to gather the needed information. We're going to answer part of these problems in 7a and b. So to start, what strategy would you use to find the approximate volume of the sphere? We could use a ruler to try and find the center of the sphere, and then measure from the center to the outside edge to find the radius. If you have a ruler, go ahead and try to determine the radius of that sphere from the page in your book. You may also measure the diameter and then try and cut that in half to find the radius. I have that the diameter is about 5¼ inches, or 5.25 inches, which would mean that the radius is half of that. So if I split 5.25 into 2 sections, that gives me a radius that's about 2.625. And we're going to use that to help us find the volume. 4/3 of the radius cubed times pi, but it says we're using 3.14. So we'll start by cubing 2.625. Which is 18.087890625. And remember, we said we're not going to round until the very end. So we'll take that big number and we'll multiply by 4 and divide by 3. And then multiply that by 3.14. If we're keeping the tens place. That is 1 decimal spot, so we need to look at the next one. The 2 is below a 5, so it rounds to 75.7 inches cubed. That is the volume of a sphere. Remember, you're using that formula 4/3 radius cubed times pi, which has been derived from the formula we used for a cone and a cylinder.